square form. Okay? You have a square, the length of the square is given, the side of the square is 2.5 centimeter, and then the charts are equal in magnitude, and they are, some of them is positive, some of them is negative. Okay? And then the question is that if I have the chart organized in the rectangle instead of square, how the scenario will change? Okay, so that's one of the potential questions for your test too. Even I can tell you now. Okay, so in the test, somehow the test one was not that good for you guys. Somehow you sleep, but my test gonna be, it had a question from the class note, lecture note, and homework. That's the only thing, three things, I gonna give the test, okay? Test from three parts. So if you do not come in the class, this is not my fault. You need to be in the class. It's an important class. And sometimes even I tell you, hey, this is gonna be in your test, some true and false question and multiple choice question, and you need to write down in the, your class notes. Okay, and so sometimes I tell you like this. Okay, this is gonna be in your test, so you need to note down those things, right? So, so you are the one who are taking the test. So with that, I already put your information about attendance credit. So so there's one column that has attendance credit, okay? So attendance credit. So whoever was in the last class, you get 5 points. I need to add the points. I haven't done the, the score added together. So you have attendance. Today I will put a bonus homework. The bonus homework. It is 5 points. It's a 5 points. I just need one question, okay? Very simple question that is not, with your class directly, but something related to science. I just want to tell you, hey, write a paragraph about something. So I like to give an assignment about the superconductivity. Okay, superconductor. What is superconductor? How we can use this superconductor? You can have plenty of resources. If you put a superconductor in a Google, it will give so many information. But do not copy from there. Okay. I want you to understand that and write one paragraph. I will write what you have to do, and I'm gonna give a test correction today also. Test correction. Okay. And you can make 5 points. So total gonna be 15 points. Okay, that will be added to your test one score, whatever score you make. So some of you might have made a 75. Okay, so if you make 15 points, it gives you 90, which is A. Okay, I give 15 points. And I also decided to give a 5 point extra bonus question in the test too, right? And I gave already this much. You also have some responsibility. How you're gonna pass this class, okay? So this is the your class. You need to care about that. So I hope that your score gonna be improved in the test too, okay? So this is one of the potential question. I just give like that right now. So there's another problem which is also very interesting. You have 3 charts. Okay, instead of 2 charts, you have 3 charts. So this is a little bit easier compared to square because you need to take into account of 3 charts. Okay, so it was like that in the previous question. So you have, if you want to consider the force over here, it was negative or positive. So over here it was positive, it was negative charge, it was the positive charge, negative charge. So Basically, if you consider the force on this one, you have this force between these two, force between these two, and force between these two. You have three forces add together because you have four charges. But if you have only three charges over here, this equilateral triangle, that all sides of the triangle is same over here. Okay. If you have organized like triangle like this, and you have so Q1, I mean this is positive, and this is positive and negative over here. I didn't write the all Q1, Q2, and Q3. Okay. So three charges are located at the center of, at the corner of equilateral triangle as shown in the figure below. What is the net electric force? You need to find in the magnitude and direction acting on the top charge Q1. So if you consider this charge Q1, what is the net force acting on this one? Okay, Q1. And you have given the D. Okay. So in the equilateral triangle, if this is D, this is also going to be D. This is also going to be D. Because all sides of the equilateral triangle is same, and all angle is same. It's going to be 60, 60, 60. Okay. All angles they are equal. Okay. That's the property of an equilateral triangle, and you might know from the high school. Okay. So I also have some hint over there. So and I also have an answer over here. So basically, your job is to find what gonna be the net force. Okay. So if you consider this charged particle, okay, I just give a hint. Okay, these two charged particles, this is positive, they repel each other, right? The force on this one gonna be, the force on one due to the presence of second F12 going to be that position. Do you agree with me? Because this positive, they repel. You have one more force coming from this charge. This is positive, this is negative. They attract. The force going to be this way. F, force on one, right? So if you take a look on this one very carefully, you have a two force, F1, 2. Now another force you have F1. You have two vectors. Again, use the same way that this is the x-axis, this is the y-axis. You resolve the vector and add them together. So you have to find a net force, which is net force going to be F net equal to F12 plus F1. Just add them together. But they cannot be added together since they have a different direction. You need to use some rule, okay? Vector addition rule. For that, you need to know what is the angle that it makes in the x direction, what is the angle it makes in the x direction. So here, if I do some tweaks over here, in the x direction, this is the y direction. Now, what will be this angle? So this angle, this is going to be 40 degrees because you are dividing in a half, right? So the total angle is 90, right? So it's going to be 90 minus 40 is going to be, this is going to be 60, right? Where is that? 60 degrees. Same thing over here. The total angle is going to be 90 degrees. So this line, this is the 60 degree, 30 degree, this is going to be 30 degree, and this is going to be 60 degree. So this force makes an angle of 60 degree with the x direction. This also force makes angle of 60 degree. Then use the vector resolution to get the net force. Any question about that? I always solve like the difficult problem. Most difficult one was like a square, and practice the rectangular one also. And this problem I leave you for practice. Here I just put everything over here. Whenever you solve it, F1 to value with that value, F1 to with that value, and even I have that diagram for the course. And you have plenty of resources. You can go to Help Lab next week, or like even this week, right? Or you can come to my office, office hours for you, okay? I don't mind to go through the lecture note, homework, anything related to, class, okay? Just you need to have a motivation to come to my office, okay? So I don't mind. Most of the time I'll be in office, so even if I'm doing something, I can just leave my thing and then I focus on you, okay? All right, so with that, I think we finished this chapter. So we're gonna go something, another interesting topic, electric field, okay? So electric field, so let me explain about this field. It's very interesting that, so what is the electric field? So in general field, we talk about a lot about field, okay? So this is electric field, electric field. Electric field, but you might have thought about other things. There's a magnetic field. The magnetic field. You might have thought about, gravitational field. Gravitational field. If you have taken like thermodynamics, I don't know how many of you guys taken thermodynamics class. You may not have taken. So you have some temperature field, okay? Temperature. Some people say heat field, okay? Temperature field. Temperature field. What exactly mean? This is very important that you should have some concept. You get a very good score, like in the exam, you solve it, how to solve it. But if you do not know how to explain, that is also not a learning. Okay, you need to learn some basic thing about the physics. Okay, you talk about electric field, what does that mean? I do some mathematics over here. That's just math. Math doesn't speak, it doesn't speak. Like you have something written over here. This one doesn't speak. You are the one who speak, okay, in front of people. Okay, math is just backbone for us. Physics without backbone, it doesn't move. Okay, if you have a car, you are driving straight path, and you are going to lava. If you know what is the initial velocity, if you know your acceleration, you can easily figure out what's going to be the time it takes from going from here to lava using the math formula. Okay, so basically math gives a support for physics to speak. Without math, basically physics is nothing basically. If you take a look on the Albert Einstein theory of relativity, I don't know how many of you guys know about that. He has done so difficult calculus, calculus, calculation, integration, derivation, everything. That's very heavy calculus. Okay? So basically, ultimately, he got E equal to mc squared. Very simple formula, but he has got tons of math. Okay, you can read about his calculation. Some people are doing their whole. It's like a small calculation as a PhD thesis. He's so genius that he could use his knowledge, and that we can even understand him. Whatever he has done, we cannot understand. Somebody already, have answer for you, but you cannot decode it. Okay. So anyway, so over here, I'm trying to tell you that hey, you read, you hear about this one a lot in your daily life. Electric field, magnetic field, gravitational field, temperature field. What that mean? If somebody tells you, hey, what is the gravitational field? I mean, we recently launched a rocket to Moon lander. NASA launched recently in coordination with Houston, right? There's a company, like some private company, besides from the SpaceX, from the Elon Musk. Some people are joining to the NASA to launch the rocket to the moon lander. I don't know how many of you guys know about that. So basically, whenever we talk about rocket science, we definitely do the work with the gravitational field. Okay? So you are going from Earth to Moon, so you need to cross the gravitational field of Earth. And you need to enter the gravitational field of Moon. Okay? This kind of information, whenever you see, then you can connect, hey, I mean, I took a Dr. Shrestha class, and then, okay, this is the what like people are talking. You need to coordinate with that. Okay? So anyway, so let me talk about the easiest one that we can feel. It's called temperature field or heat field. Some people say heat field. If you take the thermodynamics class, you can easily figure that out. Suppose you have a heater, okay? Suppose you have a heater in the room, okay? Basically you have some coil, you pass the orange, and then you this, whatever the very resistive, it can be like tungsten or some other nichrome or something like this metal, it heats up and it produces heat in all directions. Heat can travel from one point to another point, and there are three ways: that conduction, convection, and radiation. So basically it transfers to this one on all directions, in all directions in space. Now, how I feel that there is a temperature field or heat field? Okay? If I go from outside, let's say it's a door, you enter over it, as long as you reach in this boundary, okay, you feel okay. The weather outside was so cold, I feel warm. Right? I feel warm. Okay, I got a heat. My body can feel that, okay, there's a heat field or temperature field. You can go from this direction, you will feel still cold, but as long as you reach over here, you feel okay, I feel warm. That means I have some heat field is over there. So that means the field in general means that the region of space where you have that heat is over there. It's called heat field. Heat field. Okay? So you have some warm weather or warm temperature over here. The same way, if somebody talks about the gravitational field, I already explained a little bit about that. It's a region of space. It's a region of space around some planet. Let's talk about some planet. I mean, Earth is easy, okay? Earth. We are here. You cannot have like gravitational pull all the way. Outside. You have some region. If you fall within this region, you basically come back to the Earth. If you jump up to this height or this, space, you can come back to Earth because it pulls towards the Earth. If you pass this one, you never come back. So whenever you launch a rocket, you need to make sure that you have enough fuel to cross this boundary so that you go to the next planet. Maybe you go to Mars, you go to Moon or something like that. Okay? So this is called gravitational field. Okay, I introduced this too. Now, it's easy to explain what is electric field. The electric field is a field produced by a charged particle. Okay? It's a field produced by a charged particle. The charged particle can be like a positive or negative. Okay, so I have a charged particle over here. So within like some space, some region, this produce a field. That is called electric field. Electric field. Same way you have a magnetic field. So inside the like if you have some bar magnet or something, so you have some magnet. If you have some magnet over here, North Pole, South Pole. So within some space over here, you have some field. I mean, you have magnet. Magnetic. Okay, so I think you got some idea about what is the field means, right? I mean, simple talks, hey, what is the magnetic field? It's a boundary of space where magnet produces a magnetic field. Like we have a NMR machine over here, that has a very strong magnetic field, okay? So you have a device over here. I don't know how many of you guys have been there in NMR machine. A very strong magnet that is made out of superconductor. And there's like a one ring outside that, and like a one symmetric ring over here. That, okay, if you have a pacemaker, do not enter there because you have a so strong magnetic field. Because if somebody has a pacemaker, if you go into that boundary, you are already get affected by the magnetic field. Okay, and if you have a wallet that has your bank credit card, something like that, you are enter over there because the information will be wiped out. So whenever I go there, I just put my wallet back to my office. One day I enter there. Okay? If I have some magnetic stuff, let's say my watch or something, or my belt, I'm not supposed to enter there. Because if you cross this boundary, you are exposed to magnetic field, and this is very strong magnetic field. Okay? So how I feel there is a magnetic field? I do not feel anything, but I feel only if I have something magnetic object. If I have some magnetic object, let's say iron piece, it will be attracted like that. If I have an iron piece over here, it will come to this place. So basically this is how I feel it. There is a magnetic field. I cannot see magnetic field with my eyes. My skin or my sense doesn't feel, okay, there is a magnetic field. Like in a temperature field, while you enter over there, okay, I feel hot, okay, there is a temperature field. No. So magnetic field you cannot realize. You can realize the gravitational field, if you there, you fall on the ground. So basically there's a gravitational force acting on me. Okay? So this depending on what kind of field you are talking, there's a different ways to sense it. For the magnetic field, you need to have some magnetic object. Let's talk to this topic that we are going to talk about. How I feel that there is an electric field. This is a question for you. I told you about the heat field. If you enter, okay, I feel hot because my skin can sense or my body can sense. If I have gravitational field, if I have some object, if it falls toward the earth, okay, I'm inside the gravitational field. If I have some magnetic object, there is no force that attracts towards the magnet. But if I have within this boundary, this magnetic object, it will force towards that magnetic force. Because if you have a magnet and some ferromagnetic object like iron piece, it goes there. And one of you guys can tell me how I feel that there's electric field. Yeah. Light bulb? No, I have one charged particle over here. Yeah. I'm sorry? Sock? Like that electric sock or something like that? But I'm not touching over here because this is like isolated charge over here. It's like sitting over here at the center. But I'm just over here, I'm just walking like that. Okay, how I know I'm starting to match electric field? My body cannot feel it. To be honest, my body cannot feel if there's electric field or not. Okay? So the best way is to figure out is that you bring another charge particle. If you have some I call this test charge. Test charge. Test charge particle. The test charge particle is always will take positive charge. I will take a test charge as a positive. Okay, this is a convention. Okay, I mean, do not tell me here I define myself. No, it's a convention that whenever we have a test charge, whether we have an electric field or not, we always take positive charge. Now, if my test charge is over here, there is no interaction because this one doesn't feel anything about this electric field. Now, as long as I am over here, okay, I have electric field due to this one, okay, I have interaction. This is positive, I am pushed back to that place. Okay, basically, to find an electric field produced by a charged particle, I need to bring or test charge. Okay, or if I have a negative charge over here, negative charge, this is positive, okay, I'm going to push towards that charge. That feels that, okay, I am inside the electric field produced by a charge. Okay, so this is how we feel it. Depending on what kind of field it is, we have different kind of field we can define. We can define the electric field, gravitational field, magnetic field, like that. Okay. So depending on what kind of field it is, there's a different way to guess whether the field produced by that electric or magnetic or gravitational field. Okay. Anyway, we have some writing over here. If you have a time, you can read that. So you have a charge Q1 and Q2. This charge Q1 and Q2, if they are very far away from each other, they do not interact. Okay? Let's say you have a charge Q1, and if the charge Q2 is like a very infinite distance, the electric field produced by this Q1 is going to be 0. So if you bring closer, and there's some space around that, then only after that, this charge Q2 will feel the electric field produced by this charge Q1, and it will either attract or repel from them. Exactly over here, if you are very far away, it will not feel the electric field produced by the whatever charge we are talking. So as long as you are closer to this one, you start to have an interaction. Either interaction will be attractive or repulsive. Okay, so this is about the electric field. Now, this is the physics part. We're gonna go to math. Okay, so we can derive some formula for the how to find electric field. So to find electric field produced by a charged particle, so it's going to be mathematical definition. So how to find an electric field produced by a charged particle? So basically, I consider a very point charge that this, you don't have a. So it can be either positive charge, negative charge, doesn't matter. So according to the formula, so to find the electric field produced by a charged particle, it can be either positive charge or negative charge over here. Let's say you have a charge, and you can give a capital Q as Q. Okay. If I want to find the electric field due to this charge at a distance of r from this charge, this point P is at a distance of r from this charge, then I bring a test charge over here, Q0. Okay, I bring a test charge to that point. If I want to find electric field produced by this charge Q at a point P at a distance of r, I bring a test charge over here Q0, and I calculate the force. Okay, I calculate the force at that point. So force is given by, according to Coulomb's law, the electrostatic force between this test charge particle and Q is given by K, Q, magnitude of Q, Q0 divided by R square. the magnitude of the test exercise. Right? There's a force between these two charged particles, and that is given by the Coulomb's law. Now, force is a vector quantity, and this is Q0 is positive charge, this is positive charge, they repel, right? Basically, your force gonna be along this. Do you agree with me? They repel, right? Now, the electric field is defined as, according to the formula, electric field is defined as electric field is defined as Fe divided by Q0. So, this is the definition of the electric field. So, over here, Fe is equal to Q0 divided by Q0. So this is positive, it cancel out. So electric field due to a charge Q at distance R is given by electric field due to a charge at a distance of R from the charge is given by this one. And electric field is a vector quantity. So electric field is a vector quantity. So electric field is a vector quantity. Okay, don't be confused. I'll ask this question. And electric field is a vector quantity. Okay. E is a vector quantity. Vector quantity. How I knew it? In the formula over here, you have electric field and you have electrostatic force. Q0 is a charge, it's scalar. It's scalar, okay? Charge is some scalar, it doesn't have any direction. You have two vectors over here, because this is a vector, that means it should be as a vector. Okay? You have two vectors over here, and you have a positive sign over here. That means both of the vector, they point in the same direction. Electric field and electrostatic force both point in the same direction. Okay? So this is about the electric field produced by the charged particle at a distance r. If you take a look on this one, the electric field produced by a charged particle depends on how strong is the charge, or what is the magnitude of the charge, right? Magnitude of the charge and square the distance from the charge. What I'm trying to say over here is that you have some electric field at this point. If you go very far away, the electric field will decrease because you are dividing this square. Okay? If you have a R distance over here, if you go to 2R distance, let's say E2, this is E1. If you double the distance, by what factor electric field will change in this point, let's say P prime? Did you follow what I mean? If you double the distance, because the electric field depends on distance, if you double the distance, by what factor electric field will change? This is one of the questions that I can ask in the S2. Yeah. 1/4. It decreases by 1/4 because you can double this one. So if I have electric field over here, E1 is according to this one formula, K Q over r square. So over here it is going to be k q bar. Now distance going to be 2r. So 2r square. So if you do mathematics over here, it is 2 square 1 over 4. And k q over r square. But this is k q over r square is e1. You have e1. So you have it is going to be 1 over 4 to our. The electric field going to decrease by 1. Okay, so this is how you solve it. Okay. So anyway, so these are some positions that. So it has like an electric field, decrease, like at what point? At what point electric field will be 0? At what distance your electric field will be 0? Because you are like decreasing on like the distance. At what point your electric field will be 0? At what distance? Can you imagine? It's decreasing, right? At some point it will be 0. At what distance your electric field will be 0? Any one of you guys can tell me? No? Yeah.
I'm just gonna go off a guess. Isn't it gonna be infinite?
It's gonna be very large number, and we call it infinite distance. Yeah, you're right. So it keep on decreasing, and it keep on decreasing at large distance. It's also long range force. So basically, a large number in physics we call infinite. Okay, so that's the reason. So it will be 0 at infinite distance. So this is about the electric field. I just define the electric field and electric force. They're gonna be like the same distance like this. Okay. So if positive charge is gonna be this direction. If somehow if I have a negative charge over here, how the scenario will change? So this is negative charge, this is going to be positive charge. So instead of like electric field in this direction, you have electric field going to this direction. Because they attract this one. So electrostatic force and electric field, they have a same direction. If this one points this direction, I have also electric field. Okay? So depends on what kind of charge you have. The electric field from the either positive charge or negative charge. It depends. Okay. For example, in this figure over here, so you have a negative charge over here, and then you have like a test charge positive. So electric field gonna be along this direction. Okay. So it depends on what kind of charge it is. Okay. Now I'm gonna upload another lecture note after some time after this class, but I'm gonna talk about this interesting problem and then finish the class. So after we know that electric field, let's do like some problem over here. It's a very interesting problem, and it gives the information about how to find charge on the sphere. And if you have a sphere that is hanging on the string, what is the tension force in the place of electric field? Okay, so let me talk about the tension first. Tension is a force. In the physics, you might have learned about tension. Okay, tension is a force. Okay, tension is a force that usually happens on the string or string or rope. Okay. Suppose what's the tension you might have run in the physics 1. Okay. Suppose you have an object hanging in a string. Object of mass m that is hanging on the string. Okay. Now, We have a gravitational pull Fg equal to mg, which is like also we call it's a weight, okay? What is the downward direction? Now, I have same mass, okay? But I don't have string. If I don't have any string, it will fall down. I think you agree with that, right? Because it's like something is pulling down. But whenever I have a string that is hanging on the string, this one stays in the place. Why? There should be another force to balance this force. That should be in the opposite direction. That force is on the string, we call it tension. These two forces, they are equal in magnitude but opposite in direction, so that they cancel out, okay? T equal to, this is called tensile force. Now, once I introduce what is tension, let me give you information about this from over here. If you want to try yourself, that is fine. But I can give a hint how to solve it. This is very interesting because it combines your knowledge from physics 1 and physics 2. What is happening over here? A small sphere of mass 5.1 grams is hanging vertically from the insulating thread. So it's like a pendulum. You have like some rigid support over here. You have a string, and you have some sphere hanging. And mass is given, and you have given the length of the thread, 12 centimeter long. By charging some nearby flat metal plate, the sphere is subject to horizontal electric field of magnitude 7.2 10 power 5 Newton per coulomb. Okay, electric field is given 7.2 times 10 power 5 Newton per coulomb. You have your electric field. Let's consider electric field is along this direction in a positive expression. Okay, you have like electric field over there. As a result of electric field, the sphere is displaced by 6 centimeter horizontally in the direction of electric field. The electric field is along this direction. Because this is charged sphere, this interacts with this electric field and it displays to some point like this, and this displacement is given 6 centimeter. Okay, they are given this 6 centimeter, the displacement. And the length, this length is same because you have a same string, you have not changed the length. The length is given 12 centimeter, right? Yeah, 12 centimeter. So given this information, you have like 3 parts over here. What is the angle theta that the thread makes with the body gun? This thread makes with the body gun. Theta. I need to find this theta value. That's easiest one for you guys is what is the theta value over here? The geometry, right? The geometry, nothing else. This is a right angle triangle. And this is a right angle triangle. Right? This is a right angle triangle. You have this theta. So this is opposite of 90 is like a hypotenuse. This is opposite, right? You have opposite and hypotenuse. Which trigonometric function gives the relation between these two sides? Sine. sine, just use the sine theta. Sine theta is like is 6 centimeter, 6 centimeter divided by 12 centimeter. And like you do mathematics over here, centimeter cancel out, and it's gonna be 0.5, and theta gonna be sine inverse of 0.5. It's gonna be 5. It's easy. I mean, I just even myself, 0.5 is should be 30. This is easiest one. I mean, we just use high school geometry, but we want to solve something a little bit related to the physics. Okay, now in the part B, what is the tension in the thread? This is the one of the very interesting. So the tension, I told you that if it's vertically down, the tension is going to be vertically up, but you have a side way over here. You have a T. Okay. You have a gravitational pull over here. Let me use the different column. You have a gravitational pull from here because you have a mass. You have a mass. This is a force Fg equal to mg. Right? Now, I need to know what is this T value. The tension is a force, the vector quantity. I need to know this one. Mass value is given. Now, question is that if you have something hanging like this vertically, I have mass, I can multiply the gravity, I just get the tension value. Right? Over here, because mass is given, right? G is 9.8. Can I use the same thing over here? T equal to mg. Do you think that this force is equal to this force? No. Why? Because it's tilted. It has some orientation different than the vertical. Right? It has some angle over here. If you consider this is the x direction, this is the y direction, you have some angle. Isn't it? This is equal to mg only if you resolve, let's say this is an alpha angle, right? Alpha angle. The angle with a negative x direction. If you have a vector that makes an angle alpha with the x direction, physics 1. If you have a vector A that makes an angle of alpha, let's say, or theta, x component is going to be ax equal to a cosine theta, y component ay equal to a sine, let's say, theta. Right? This is what it is. Now, if you have an angle, all this negative x direction doesn't matter. This component will be, let me erase this one, okay? T cosine alpha. This is going to be T. Right? In the y direction. What do you think? If this is the alpha angle, it makes the angle alpha with the x direction, all the negative x direction. T will be T cosine alpha. Y component will be T sine alpha. Right? Now, if you take a look, this is vertically down, mg. This is vertically up, sine alpha. They should be now equal. That means in the part B, I just clear this one, okay? In the part B, T sine alpha should be equal to mg. Right? Because T sine alpha is vertically up, mg is vertically down. I need to find tension value. You divide the sine alpha on the both sides. Sine alpha, sine alpha. So this one cancel out, and T is equal to mg times sine alpha. Mass is given, gravity is 9.8. If I know alpha value, then I can easily use this equation. Right? This angle I got is 40 degree. I just got 40 degree. This is 90. The total angle is 180. So it's 90 plus 30, 120. What should be this angle alpha? 60. No, you just put 60. Mass is 5.1 gram, 5.1 gram. So 10 power minus 3. So gravity is 9.8 and sine 60. So whatever the number you get, that's going to be tension. Tension is the force is equal to, okay, Newton is the answer, the unit for this. Any question about this from part B? And this answer over here, I think you get maybe the closest to that number. Let me know whether you get different than that answer to part B. Any confusion or something? Because this is a very different class, and I want to make sure, because I keep on talking, and then if you do not follow, it's gonna be a waste of time. Right? Always can ask me student, tell student that. I keep on talking. I finish one chapter in a day, but if you do not follow, it's a waste of time, right? I am here to tell something about physics. Okay, I want to I'm not expert. I do not have expertise in physics. But I have a little bit that I want to share with you. That's the reason I'm here. Okay. So so anyway, any question about part B? You have part C, where you need to find the sphere, charge on the sphere. And do you want to try that one? Part C. No? If I solve everything over here, it won't be homework basically. You copy and then just submit, right? But I'm gonna give a hint how to find the part C, okay? Now, so this is like something I want to tell you. You need to understand what is happening over here. You had a sphere. You have a sphere that is hanging over here, the sphere of some mass. And you have an electric field over here. Electric field over here. This sphere displaced from the original position and reach over here. This one is charged sphere, because if it was there is no charge, it doesn't get influenced. Okay? So if it moves in this direction, then you should have a force along this direction. This force is electrostatic force. Okay? So let the Q be the charge over here on this sphere. Then, if you take a look on the electric field definition, electric field is given by Fe divided by Q. And if you want to find the electric force Fe, it will be Q times E. So force gonna be Q times E along the X direction. And then we already know what is the T value over here. We already have a construction over there. I just want to like this 90 degrees is alpha, and you have this one Y direction. So you have the force along this direction is T cosine alpha. It was like that, right? Over there. This is the force in the left direction, and there's a force in the like a MG. So whenever you compare T sine alpha equal to MG, you got T value from there. But you have another component in the left, T cosine alpha. You have another force in the right direction, which is Q times T. They should be equal. Okay? You need to compare this, horizontal component. So let me do over here. So this force T cosine alpha should be equal to force on that direction Q times E. In this equation, I need to find the Q value, so divide E on the both sides, electric field on the both sides. So E cancel out, Q will be T cosine alpha divided by E. Okay? The T value you got from the part B times cosine. Angle is, I don't know what was angle, 60 degree. 60 degree. And you have electric field is given. Electric field value I just erase 7.2 times 10 power 5. So whatever the number you have over here, that going to be charged in the coulomb. Okay, charge of the sphere in the unit of coulomb. Any question about this one? I mean, you might, I did the solution over here, but I want to introduce one small thing about this one. Electric field lines. Electric field lines. It is finding the direction of electric field. We just use like this method. I just like spend few minutes, okay? So I will spend few minutes over here. So if you have seen like a bar magnet, and in the textbook, you might have seen this kind of figure, okay? So North Pole and South Pole over here, and you might have seen that there's a magnetic field lines coming over like this, okay? Here is like that. Have you seen this kind of thing, like a picture? The bar magnet, in the big, either in the book or like some literature or somewhere, you might have seen like that. This is called magnetic field lines. Magnetic field lines. The magnetic field lines, they originate from the North Pole and go to the South Pole. It gives the direction of magnetic field at any point. This is how you define the magnetic field direction. In the same way, if you have a charged particle, to find the direction of electric field, you draw a line that originates from the negative charge and reaches to the positive charge. These lines is called electric field lines. The electric field lines originate from the negative charge, as a positive charge, and it reaches to the positive charge, as a negative charge. So electric field lines, there's a couple of things over here. It originates electric field lines The important points about this one, you know, I will ask in the test. It originates from positive charge and end on negative charge. So positive charge the source, negative charge the sink. You know, you start from here. Number two, a tangent at any point gives the direction of tangent at any point on the field line, give the direction of electric field. So basically, if you want to find the electric field at this point, let's say, you just draw the tangent over here. This is the direction of electric field. If you want to find the direction of electric field over here, you just, you know, like draw the tangent. Okay? Number three, that is also very important. The electric field lines never cross each other. Okay, this is gonna be electric field lines. Okay, now I already talked about it. So they never cross each other. They never cross each other. So whenever you draw electric field lines, definitely you start from here, and if you draw like that, and they cross over here, that will be wrong. They never cross each other. Why? If they cross each other, I can draw two tangents. I can draw two tangents at that point because like they have two lines. Right? Because it's like a tangent to this line, tangent to this line. Electric field is a vector quantity. A vector cannot have a two directions in a given point. Right? If they cross, there will be two tangents, that means there is a two electric field direction. A vector cannot have a two direction at a point. That is not possible physically. Okay? That's the reason that they never cross each other. Okay? If they cross, it violates the physics law. Okay? Number 4. This is number 4. Okay, I'm gonna finish now. So number 4, the number of lines, number of here lines depends, is proportional to directly proportional to the amount of charge. So charge value, okay? Amount of charge, okay, charge value, okay? If I have more charge, if the magnitude of the charge is more, it will produce more. So over here, let me quickly talk about this one and let's finish the class. If you have a positive charge of 1 microcoulomb and we have a positive charge of 2 microcoulomb, if this one produces 4 electric field lines, since the number of lines depend on the magnitude, you have 1 microcoulomb, then 2 microcoulomb will produce 8 electric field lines because it's proportional to the magnitude. Okay, something like that. 6, 7. Anyway, so this is the information about the electric field lines. We'll talk about briefly in the next lecture, and then after that I will talk about other things. So see you next week.
Okay.